Hello, welcome. Firefox. So, this is Khan Academy, right? It's an amazing place where you can learn. So I just made an account, and this will be my first. So I've been doing a Haskell series with Learn You A, covering going along the book Learn You A Haskell for Great Good. We've been now at list comprehensions, and this is basically. I thought of this before once, and I tried it a bit, and I think it will be best if I just start at least making recordings about it, and sort of as a side project. So also my wife works as an assistant in school, so she helps someone who has difficulties in learning, and they're doing math, and it's so hard. Well, hard in the sense that they do all this manual kind of 19th century math, which, yeah, I don't know how to put it. I mean, I like math, but it's like the way that it's presented, it's just not computational. Like yeah, this will probably come bad, but it would be nice if they could somehow mix the computation, learning about computation and computer science, together with math. So instead of kind of even separating the computer class in school, which is mostly based on operations, like how to use Word or how to use Excel. They do Scratch, which is great. They do Scratch, but I think it'd be even better that they use computers when they learn math. Of course, that will probably happen, but and that may be too big of a jump or a leap to do it right now. But okay, to keep it short, I think it's an interesting idea. Like, look at the list comprehensions, like because you kind of generate a list of results, and you need to understand how the function works and how it's declared. So even just describing the x, like, or check this. This is actually, so multiplying two lists of numbers. You have the numbers 2, 5, and I think this is something very elementary. You have a list of 2, 5, and 10. Then you have a list of 8, 10, and 11. Now, maybe it's not important what's a list now, but not important. Yeah, I guess everyone who knows a bit of Haskell is watching this. Or, yeah, I shouldn't assume things. I'll just go along. So we have three numbers, 2, 5, and 10, and we have three numbers, 8, 10, and 11. So basically, in school, you would do some kind of I still now I don't remember. Like, yeah, like 2 times 8 is 16, and then 2 times 10 is 20. And then you see, but yeah, you would never make a list. I think the assignment would be to really to multiply this whole thing, I guess. Like, wait, let me just go to, I'll just use it here. I guess it would be 2 times 5 times 10. And then, yeah, you would actually multiply that with 8 times 10 times 11. And you get 88,000. Yeah, you would always get some kind of a result in math in school. But that result will be like, it will be within a scope, but it will be only just one result. Like, the x is this number. So there is no description of any kind of, properties of this result, or like, you see, this is nice too. Like you have a list here, you have a list here, and you kind of get a list of results. Maybe you can, multiply them. That would be the next step, I guess. And this is, I think this is more interesting also for students. You would get, if they would actually use functional programming to learn math. And I remember there was a book, I think it was called Python Math or something. Python Math book. Learn, whatever. Doing math with use programming. Yeah, I should check this book, Doing Math with Python, Use Programming to Explore Algebra, Statistics, Calculus, and More. First edition. Describe your data with statistics. Yeah, it would be nice to make something like for children. 14 years and up. Rating age 14 years and up. Yeah, that's... Yeah, I don't know if someone... I haven't really made an investigation if someone has done this, but I thought the idea was... Haskell on math. Pick a username. Yeah, let's pick something. Nickname. That's my name. Yeah. Haskell. Math on Haskell. Math on Haskell. Math on programming. Coding math. Math code. Math code. Let's call it math code. Who are you? I'm using Haskell, functional programming language, to solve all the math exercises. Basically, I want to see how I can use a programming language to bring basically in learning math and learning. Okay, I can write. Let's confirm who you are. I didn't log in. And wait a second, I'll just solve this and then I'll be... So let's continue. So I've made an account, math code. Pick a username. I'm using, algebra basics, arithmetic, foundations. Maybe we could start, I don't know, understand fractions. Like all of these, you see all of these things, maybe I can do with Haskell. Pre-algebra, algebra basics. Ratios, percentages, exponents, intro, and order of operations, factors. Let's check what's pre-algebra. Factors and multiplies. Understanding factor pairs. Finding factors of a number. Factor pairs. Oh, I should watch the videos. Understanding factor pairs, reasoning about factors, multiples, factors and multiples. Let's maybe start with questions. Factor pair. Google Classroom, Microsoft Teams. Okay, let's go. Yep, this is the new homes. Check. 40 students are going on a field trip to the aquarium. Yo, it's a lot of words here, yeah. 40 students are going on a field trip to the aquarium. Every student needs to be in a group, and all groups must have the same number of students. Use what you know about factor pairs to complete the table. 40 students are going on a field trip to the aquarium. Now, every student of those 40 needs to be in a group, and all those groups must have the same number of students. Use what you know about factor pairs to complete the table. Number of groups. Oh, number of groups. Oh, this is just like mind thinking. Like number, if there is only one group, there's 40 students. If there are two groups, there is 20 per group. If there is 3 groups, no, if there is 4 groups, then students per group is 10. So how would you put this in code? So the number of groups, the number of students per group is, check, yeah. See how we answer this question. Yeah, it's not showing me. Great. Understanding factor pairs. Let's check the video.
What we're going to do in this video is talk about factors and factor pairs. Now, when we talk about factors, these are really numbers that can be multiplied together to make some number. So, for example, if I were to talk about factors of 6, I could multiply 2 times 3 to get 6. And so we would say that 2 and 3 are factors of 6. In fact, we would also say that 2 and 3 is a factor pair for 6, because when I multiply those two, I can get 6. Now, to think about all of the different factor pairs for a number, we could think about it in terms of area. How can we make a rectangle with area 6? Well, you could do it if it's 2 units by 3 units, so it could look something like this. I'll just hand draw it. So let's say it has... So let's say our rectangle looks like this. So it has 2 rows and then 3 columns. And let's say these all have equal area. It's hand drawn, but you can see that the area here would be 2 times 3, which would be equal to 6 square units. Now, what are other ways to get to an area of 6? Well, you could have something that is 1 row, but then it has 6 columns. So maybe it looks something like this. It looks like this. So it's 1 row, and then you have 1, 2, 3, 4, 5. And I want them all to be roughly the same size. So it's 1 times 6 would be also an area of 6. So that would be another factor pair. We know that 2 times 3 is equal to 6, and we know that 1 times 6 is equal to 6. And these are actually the 2 factor pairs for 6. And we can do it with larger numbers. We could think about, what about all the factor pairs for something like 16? Pause this video and see if you can think about that.
All right.
Well, I'll set up.
Yeah. Well, where do I have console? So it's interesting. So if I have a 6, how do I get factors from a number 6? And with programming, it's so cool. Like, if you understand this, then you don't need to can get factors from any number, but you know the methodology. That's an interesting problem. Let's open up. Yeah, I can't believe I'm doing this. Wait, Haskell factors. Haskell factors of a natural number. Haskell program to display factors of a number. Let's check. List comprehensions. All right, that's what we want, right? Haskell program to display factors of a number. In Haskell, we can list comprehensions. We can list comprehension, filter function, and recursion to display factors of a number. In the first example, we're going to use factors n, x, n mod x is 0. Oh, that's what we did before. So like, if I have an x, let's try this, and into the x goes what? Goes x. 1 to n. Well, it goes x. Into the x goes x. And n mod, I don't know, will this work? N mod x, n mod x. equals 0. Did he write? I'm just trying to make this really simple. No, wait, let's try it actually with 6. How would I do this? 6 mod 3 is 0. Why am I doing 6 mod? Algorithm, wait. We're going to see. Oh, it outputs the factors. Let's try it again. I want to understand. This is a good beginning. So we have factors n is what? It's an x. All right. And what goes inside of the x? It goes a list of numbers 1 to n. It goes a list of number 1 to n. And n is a mod. N mod what? N mod x is 0. So factors 6 is 1, 2, 3, and 6. Factors 16, as he said now, is 1, 2, 4, 8, 16. All right. This is cool. So how do we make I want to make a more simple kind of version and then come, because this is a generalized factors n. I want to make something like, if I want to 6, let's see, factors of 6. So 6 was input, so 1 to 6. Oh, because it's a list of numbers. We want a list of pairs. Pairs, factor pairs. He was saying about factor pairs. Why did he say about factor pairs? Oh, this is more simple. Yeah, because he was saying like 2 numbers are pairs, but they are more of these pairs, like 1, 6, 1, 2, 3, and 6. 1, 2, 3, and 6 are all the factors. I guess this is kind of educational thing, because you start with pairs. Because 2 and 3 make up 6. But how many of the factors make up? Yeah, I think this is more functional. How would you make a pair? Wait, let's try this. X, and then X goes what? In X goes, let's say 6. Do we do it like that? 1 to n. 1 to n. Factors of 6. Yeah, this is the most simple. No, but I should use something for just this example, like 6. Factors n. Factor 6, 1 to n. Oh, it's a list. It's an infinite list. An infinite list up to the factor number. So how would we do with it? 1 to n. Won't work like if we just input. Well, it's some kind of a list. But it is from 1 to x. Maybe you could do it like from 1 to x, because we have an x. Will this work? And n mod x. Yeah, I don't understand this. Let's try with ChatGPT. this is a general function for any number, but can we make a simpler one that would like only work with a number 6 and without the factors n, but only with the list comprehension used in the interpreter. All right, this is what I wanted, right? X 1 to 6. Ah, so silly, right? You see this? So x, and into the x, we're going to put a list of numbers up to that x, up to 6. Because let's say we want the factor from 6. So the factor from 6, this list comprehension directly generates the factors of 6 by iterating over the list from 1 to 6. All right. Let's go to GitHub. I'm going to start actually making notes of this. Maybe I'll go to Notion, Haskell Math, or on GitHub. Maybe better on GitHub so that I don't have to, you know, I can fix it later. So your repositories, Haskell Discovery, updated yesterday. Should make a new one like Con Math, Haskell Con. Scoper. Yeah. Wait, let me just pause this for a moment. Right, we have our first thing, understanding factor pairs. Now this already includes a lot of things that may not be clear for like elementary kind of a thing, but I guess I'll have to rearrange all this, but it's great to have some kind of a start. Understanding factor pairs. That's beautiful. Now a more generalized one. This approach does not use a named function and directly utilizes list comprehension for the specific case of finding factors of 6. Let's check this again. So we have an x. Is this an x? Factors? Or is it a list? Because we do get list. 6, 1 to 6. And mod. So this approach does not use a named function and directly utilizes list comprehension for the specific case of finding factors of 6. So, oh yes, without, so the 6 itself, mod 3. No, 6 itself mod x is 0. But what is the x? What is the x? The x itself is the list. So the x itself is the list. The x itself is the list. Because if it is, it would be better to write x's, since x's denotes a list of x. Let x's in oh, this is now using the let statement. Yeah, I wonder, like, it would be nice to use lets. So the x, so the x's is the result. And into the x's, we input the list of 1 to 6 and 6 mod x's. 6 mod x. X is the element of the x's, which is a list. 6 mod x's. Ah, it's different. 6 mod x's 0. Will this work? Yeah, 1, 2, 3. 1, 2, 3, 6. Or let x's be what? Let's do a number, as he says, 16. In what? And now, in x takes, the x itself takes a list of these x's. And then 6 mod, 16 mod, 16 mod x, 0. Yeah. I'm just trying to think what would be a most, because there are all these variations. I guess I could like copy this too as a sort of a variation of sorts. Wow. So variations. X's. What else? This is with a let. Yeah, this is a simple one. A more generalized. Variation. Specific variation. Yeah. Well, I think that's enough. And there are types here also. Integer, fic. Oh, this is used with filter. Factors and filter this filter x n mod x 1 to n. Display all the factors of a number by using recursion. Oh, this changes. Yeah, it's like the math would look completely different. Like the methodology and the progression. I think you would learn much faster. Factors n I greater than n. N mod I is 0. I factors n. Otherwise factors n. Oh, nice. Can be displayed to the console using list comparison. This is nice. I should links. Factor using higher order functions to return factors. Programming in Haskell. Oh, there's something in programming in Haskell. Factors. A list of all perfect numbers up to a given limit. Perfects. Oh, this is factors. Factors A is x And into the x, we go 1 to a. And a mod x is 0. Okay, this is what Graham, from the Graham's book, Programming in Haskell. Factor n. This is kind of the same as in here, I think. Factors n. Let's write the most generalized factors n. X 1 to n mod x is 0. Yeah, this would be this. Copy this. Good. Yeah, I guess this video is not really best. I think I should make a tutorial video. It's just me going through it. It's probably very boring. But I might keep it because it's still how I worked. Go to edit. Specific example variation. So generalized function. Generalized function. All right. This. X. Yeah, but this would be hard to explain to someone. Specific example. Right, this. This would be hard, I guess. Generalize is better. Like copy.
A little table here to think about that. And so in this column, I'll put the first factor. And in this column, I'll put the second factor. And the way I like to do it is I start at 1 and I keep working up to the number to try to figure out all of the factors. So let's start with 1. So 1 is definitely divisible into 16. And as long as you put a whole number here, it's going to be divisible by 1. And what do I have to multiply by 1 to get to 16? We'll have to multiply it by 16. So that's a factor pair right there, 1 and 16. Now what about 2? Does 2 go into 16? Well, sure, 2 times 8 is 16. So that's another factor pair. 2 times 8. We found another factor pair. Now what about 3? Does 3 go evenly into 16? Well, no. 3 times 5 is 15, and 3 times 6 is 18. So 3 doesn't go into 16, so 3 would not be a factor of 16. What about 4? Well, 4 times 4 is 16. So that's a factor pair there. 4 and 4.
They're
what about
really
5?
Doing the
well, no. 5 times 2 is 10. 5 times 3 is 15. 5 times 4 is 20. 5 does not go evenly into 16. Same thing for 6. 6 times 2 is 12. 6 times 3 is 18. Does not go evenly into 16. What about 7? 7 does not evenly go into 16. 7 times 2 is 14. 7 times 3 is 21. What about 8? Well,
yeah, I wonder if we can use this. Can we write this without the mod? Without using the mod function. One way to achieve this is to use the property that a number x is a factor of 6 if and only if 6 is divided by x is an integer. We can use list comprehensions and the lm function to check membership in the list of valid denominators. Okay, this kind of makes sense. Let x's is 1 to 6, right? In x takes a list from the x's. 6 divided, you divide 6 with from integral x lm of map from integral x's. Oh. Like write the factors using the most elementary Haskell you know. Write the factors of 6 using the most elementary Haskell possible. We can rely solely on basic list comprehension and the idea of checking if the multiplication of the two numbers equals 6. X takes a list of 1 to 6. Any. Oh, we have a lambda. X times y is 6. 1 to 6. This is nice. Let's break this down. What's going on here? What's any? X takes a list of 1 to 6, iterates over all numbers from 1 to 6. All right, yeah, that's clear. Any checks if there exists a number y in the list 1 to 6 such that x times y is 6. When you run this in the Haskell interpreter, any. It's any. More elementary version that uses only basic list comparison and condition. LM. Okay, this is better. LM. So the x, we have a list, we have x, right? And the x takes what? Takes 1 to 6. Now, what do we have to check? We have to check if an element of 6 divided by x, and what's the x? Any. X is the list from 1 to 6. 6 divisible by x from the x's. The list. LM 6 divided by 6. 1 to 6. There's still way too much typing. And 6 is x times 6 divisible by x. That's too much typing. 6x. Yeah, this is way too much. It's kind of interesting. Haskell specific Haskell variation. Another variation. Using without the mod. But it's worse. Yeah. Iterates over all numbers from 1 to 6. LM6 div 6 ensures that 6 using integer division is one of the numbers in the list. Okay. And then 6 checks if x times 6 equals 6, ensuring x is indeed a factor. Big Bay elementary x avoiding higher order functions like any. Yeah, any was a higher. This would be interesting. Any lambda x plus y. But there is a any foldable t a ball. Well, this has been long so far, and I'm still at 39 minutes mark. Wow. Yeah, this is an interesting problem, and it's taking me a lot just understanding factor pairs. Could I just link this to understanding factor pairs? Maybe I should. Yeah, I should probably understanding factor pairs. All right. We know there are 40 students. Here's complete table. Next question. Complete the table to find all the factor pairs of 30. I guess you have to use paper to solve this. First factor. Second. All the factor pairs of first factors. If second factor, so this is more like visual. Second factor is 30, then the first must be 1. And then it's 2, and then it's 15, and then it's 3, and then is what? 10. And then it's 5 and 6. So yeah, this is different way of learning. It works differently on the mind than just outputting a list. Yeah. See a step-by-step solution. Factor pair is 2 whole numbers. We can multiply to get a certain product. We are looking for pairs that have a product of 30. Well, let's try this. Copy. Let's try this. We're looking for pairs that have a product of 30. How would we do that? Using Haskell. To find pairs of numbers whose product is 30 using basic. Oh, they have to fix this with the. This is really wasting time. To find pairs of numbers whose product is 30 using basic Haskell, you can use a list comprehension that generates all pairs x, y, where both x and y come from a specified range, and then filter those pairs where the product x times y equals 30. Oh, this is using tuples. We're looking for pairs that have a product of 30. How would we do that? Let's go. Well, we're looking for pairs. How would we do that? Haskell. So to find pairs of numbers whose product is 30 using basic Haskell, you can use a list comprehension that generates all pairs. Now we have a tuple. So factor pairs, maybe we better to start with tuples, yeah, where both x and y come from a specified range, and then filter those pairs where the product x times y equals 30. Here's how you can write it. X, y. I think this would be a good project to, like, I could look for funding. You know, it'd be nice to work on this. Funding, yeah, there's all this. Yeah, anyway, something to think about. Here's how you can write it. X, y. X 1 to 30, y 1 to 30. X 1 to 30, y 1 to 30, x times y is. What does it have? Oh, wow. This is interesting. I didn't even know this. So we have a list, we have a tuple, right? X and y. We have a pair. x and y. And inside of there, x will take, inside of x we'll have a list of 1 to 30. And inside of y, we'll have also a list of 1 to 30. Can I put like in the tuple there's a list? No, I have to separate it, I guess, into each member, x and y. Now, what are we going to do? X times y. This is a predicate. So the predicate has to be that x times y equals 30. This is what I was looking for. This is a simpler way than by looking at the remainders with mod. Yeah, with mod you check the totality, right? I don't know how you would know it. Like you check there's no remainders with the mod, but here you do it like the x and the y from these two lists would have to together has to be equal to 30. The list comprehension iterates over all numbers x plus x from 1 to 30, and then it iterates over all numbers y from 1 to 30. Now, it filters the pairs, so that's the predicate. It filters the pairs x and y to include only those where x times y is 30. When you run this in the Haskell interpreter, it will produce the pairs of numbers whose product is 30. This is beautiful. All right. It's not bad. Now, this list it iterates over all numbers x plus 1, filters the pairs. This approach ensures that you get all possible pairs within the specified range where the product equals 30. One to 30, 2 to 15, 3 to 10, 5. So now we got pairs. 1 and 30, 2 and 15, 3 and... So this is more information than just having the factors themselves. These are the pairs. These are the factors. So this would be, I guess this solution would be more correct. And it's also using, you know, elementary operations without the mods and the filters. Yeah. Okay, we found it. It took me 50 minutes. But it's interesting. Was this ready? Standing factor pairs. Oh, I think I don't have to. Yeah. Exercise. Adding factors of a number. Which of the following are the factor pairs of 6 or 66? But that means you could just, you know, factor pairs for 66. And the more generalized Yeah, how would we write a more generalized function? Would be factor pairs and factor pairs and factor pairs n. So we would, yeah, we would write x and y, that would be the pair and pipe, and then into the x we put what? 1 to n, right? And into the y we put 1 to n, and x times y is n. That will be our function. Factor pairs 66. Right, factor pairs 899. This is cool. Factor pairs. So let's add this too. So a generalized function would be implemented, would be looks like factor pairs 66. This is nice. Right. 1 and 6, 2 and 33, 3. See, but this is hard. Like 1 and 6, 1 and 66. Yeah. 2 and 33. 3 and 22. Why 3 and 22? Oh yeah, 3 and 22. 4 and 16. No, 6 and 11. Yeah, 6 and 11. Check. All right, got it onward. How did we answer? 1 times 66, 2 times 33. I don't know. I think it's better to learn like this computation wise. Then you can like this stuff stays with you, and this stuff I don't know. I'll just go to the next question. A rectangle has an area of 8 square centimeters. Yeah, so there's mixing here. A rectangle has an area of 8 square centimeters. Which of the following could be the rectangle's length and width? Area is length times width. Choose all answers that apply. Oh, these are the factors, actually. So, which of the following could be the rectangle's length and width? So that's basically factor pairs 8. It's 1 and 8, 2 and 4, 4 and 2, and 8 and 1. So 1 and 8, 2 and 4, 4 and 2, and 8 and 1. We don't have anything. But here it's with area length times width. So the checking. Yeah. Question. So you see, now I can solve everything because I have a generalized function. There are 56 unicorns at Magic Camp. The unicorns stay in a large fenced-in fields. Every unicorn is in a field, and each field has the same number of unicorns. Use what you know about factor pairs to complete the table. 56, I can just use it again. 56, 1 to 56. 1 to 56, 2 to 28, 4 to 14, 7 to 8, 7 to 8, and that's it. All right, next question. Complete the table to find all the factor pairs of 45, all the factor pairs of 1 to 45, 1 to 45, second factor, and 15 would be what? 15, 3. 3 and 15, 5 and 9. 5 and 9. All right, check. Next question. Which of the following are factor pairs for 26? Factor pairs for 26. 1 to 26, right? 2 to 13, right? 13, no, to 2, 26, that's it. So here, it's interesting, here you give someone a wrong answer, and that's the way to check. Like the way to check, if I will provide the correct one, is to give me a wrong one. So I have to say, oh, that's incorrect. That means I know what's the correct. It's interesting. I think this. I don't know if this kind of methodology will stay in the future. No, that's too big of a question. What am I? No, okay. So summary. Awesome, you leveled up. 7.7 correct. 622 energy points. All right. Factors, multiples, and patterns. Understanding factor pairs. But wait a second. This is Unit 6. Is this kind of a random thing? 4th grade. What's in 4th grade? Why did I start place value? Factors. Let's start with place value. All right, I'm going to stop this video. Factor pairs. Maybe I should stop recording this just to have a better idea what I'm... Okay, 57 minutes. Stop recording.